All right, 4.6. Okay. Looking at slope-intercept form.
Okay, slope-intercept form is something you've been doing. You just didn't realize you were doing it. Get to my graph paper here. All right. Slope-intercept form. Okay, slope-intercept form thanks, sir. All right, slope-intercept form is exactly the same thing as function form. Okay? Now, what we're going to do with it is different, okay, because there's different information that you didn't realize that there is. But basically, slope-intercept form is y equal x plus b. Now, that sounds fancy, but I'm just saying this because there's no numbers yet. Okay? For example, if we had function form of y equal 3x plus 4. Okay? Well, in this problem, b is the 4. Okay? In this part, 3x is the x. All right? Now, here's what this actually stands for. If I take y equal 3x plus 4, well, the 4 is the b, which is the y-intercept. Okay, the 4 represents where the line crosses the y-axis. Okay, and that's always true. Anytime that it's in function form, now called slope-intercept form, in other words, we solve the equation for y, then the constant, or the number that is by itself, is the b, which is also the y-intercept. They're the same thing. The b and y-intercept are the same thing. Okay, now, the 3 is called the m, but that is also the slope. So, the number in front of the variable is always the slope. So the slope of this equation is 3. The y-intercept of this equation is 4. Okay? What they're going to want you to do is use that information and graph it. Okay, so in this problem, m is equal to 3 and b is equal to 4. And as I stated, m is the slope, b is the y-intercept. Zach? Not yet. All right. Now, so here's how we're going to graph this. We're going to take that information and we're going to build us a graph. Okay, we draw a graph. So, we have said that the b is the y-intercept. Well, the y-intercept, that means that the coordinates are 0, 4. So I'm going to put 0, 4 on my graph. 1, 2, 3, 4, right there. That would be your y-intercept. Now I'm going to use the slope to graph the line, okay, to graph more points. Now, we said the slope is 3. Well, we know that rise over run is equal to your slope. So that means 3 over 1. So what that means is this. It means that I'm going to go over one spot. Okay, I'm either going to go one to the right or one to the left. Now, is this a positive slope? Okay, so let me show you something. If I go one to the left for my run, okay, and then I go 3 down, 1, 2, 3, and I put a point right there. Now, if I connect those 2 points, is that a positive slope? No, that's a negative slope. So I went the wrong way. Okay? So I have to go 1 to the right and then 3 down. 1, 2, 3. Okay? Now, I look at this line. Okay, that is a positive slope line. And what I've created is what they call the slope triangle. Okay, when I used my slope to create this triangle going 1 to the left, which is negative, right? Correct? If I go left, it's negative. Okay, this is negative when I go left. When I go down, it's also negative. But the 2 negatives make a positive. Okay? A while ago when I did this right here, okay, and we drew the line going this way, like this, well, going to the right is positive, and going to down is negative. So that represents a negative slope triangle. So we didn't want a negative, we wanted a positive. Okay? Now, realistically, you need to have 3 points. So for me to do 3 points, I do the same thing. I go over 1 and down 3. 1, 2, 3. So that's my next point. So to get a better line, I do that right there, and I go through my line. Oops, it's hard to draw a line on this thing. Huh? Because a whole number as a fraction is 3 over 1. Okay, so if I have a slope of 4, if I have a slope of 5, slope of 6, doesn't matter. Okay, if I have those slopes, the rise is going to be whatever that whole number is, the run's always going to be over 1. Okay, now, let's say they give us this. Let's say they give us y is equal to 1/2 x plus negative 2. Or let's do it this way. Let's even say it's minus 2. Okay, well, first thing we have to do is change this to plus and negative. That's the first thing. So that tells us that our y-intercept, okay, so what this tells us is the slope is equal to 1/2 the y-intercept is equal to negative 2. And they want you to graph that slope-intercept form or this equation. So, if I do that, then okay, so I start at negative 2, which is right there. That's your y-intercept. Okay, so that is 0, negative 2. That's the coordinates of that point. It looks like a 6. Ooh. Back it up there. So this is 0, negative 2. Now, they've given us a slope of 1 over 2. So a slope of 1 over 2, or 1/2, means the rise is going to be equal to 1, and the run is going to be equal to 2. It is a positive slope. Okay? So I'm going to go over, so I have to make a positive slope triangle. Okay, to do that, I knew I put that in the wrong spot. I'm going to go over 1, 2, because that's my run. So going over this way, going to our right is what? Positive or negative? Positive. So to have a positive slope, okay, then I have to go do what? Go up. If I go to the right, this is positive. Okay, this is positive. So to go up, I go up 1. And this would be positive. So the two together make a positive slope. Then I do it again. I go up, I go over 2, 1, 2, and I go up 1. So there's my 3 points. And here's the slope. Let me change colors here so I don't do the same color. Okay, and with our line, we have created our positive slope triangle. Okay. So that would be y equal 1/2 x minus 2. That's what the label on that line would be. Yep. Now, obviously those they have given us in slope-intercept form. So let's say they give us this one. 3x plus 4y equals 16. Okay? Now, we have to solve that. All right? So first of all, we have to solve. Well, let me use another word. We have to rewrite the equation in function form, and also known as slope-intercept form. So, the first thing we have to do is take the 3x and move it to the other side. Here it was a positive, here it becomes a negative. So that gives me 4y equal negative 3x plus 16. Okay, next thing we must do is to get rid of the 4 in front of the y. To do that, we must divide all terms by the 4. Cancels here, and that leaves me with y equal negative 3/4 x plus 4. Now, in this particular section, they want you to rewrite it, and then they just want you to give them what the slope and what the y-intercept is. So, the slope is equal to what? Negative 3/4. And the y-intercept is equal to what? 4. Okay, so you don't have to graph that one. That's all you need for that one. All right, now, I want to ask you about two different ones here. I want to ask you about y is equal to 2/3 x. And then I want to ask you about y equal 2. Now, y equal 2/3 x. Y equal 2/3 x is a direct variation. So, if I told you to graph that, if I told you to graph y equal 2/3 x, okay, all right, if I am to graph y equal 2/3 x, well, we said that if it's a direct variation, it doesn't have the b. So it doesn't have plus 2/3 x plus 4 or 2/3 x minus 2. It just has 2/3 x. That is a direct variation, so we start here. There's our first point. We know that a direct variation, a line that is a direct variation, goes through the axis, or the origin, where x and y cross each other. So, there's my first point. My slope is still equal to 2/3, which rise over run, it's positive. So, I'm going to go over 1, 2, 3, and go up 2, 1, 2. Okay? My next point, I'm going to go over to the left, 1, 2, 3, and down 2, 1, 2. Okay, because here's y. Let me go ahead and draw the line. There's your line. Now, here is your slope triangles. There. I need to use blue. Okay, there's one slope triangle. This is negative. This is negative. So that two together make positive. Then you have the slope triangle here. This is positive. This is positive. And therefore, that's why your slope is positive. Okay? So that's why slope is equal to 2/3. Now, the other one I want to look at is the y equal 2. All right, well, y equal to 2 means that the coordinate of the y-axis always has to be 2. So that means, first of all, we start at 0, 2. Well, 0, 2 is right there. Well, where else is the coordinate of y going to be equal to 2? The coordinate of y, the y coordinate in all of those points, this is going to be 2, 2, 1, 2, 0, 2, negative 1, 2, negative 2, 2, negative 3, 2. So I have a horizontal line that goes like that. So, any time that you have y equal something, okay, y equal 2, the slope is 0, and the y-intercept is already given to you, equals 2. Okay, and so if they ask for the slope and the y-intercept of that line, then you're going to give those things. Okay? Now, I don't think they're not going to give you any vertical slope. Okay? All right, now, let's move to the last thing, and that is parallel lines. All right, parallel lines. Parallel lines have the same slope. Okay? So you can tell if two equations are parallel if they have the same slope. Okay? You can tell if two equations represent parallel lines if they have the same slope. Okay? So, let me give you an example. If I have this, y equal negative 3x plus 2, and then I have y plus 3x equal negative 4. So we want to know if those two lines or those two equations are parallel. Don't have to graph them. All we have to do is get them both in slope-intercept form. Okay, well this one's already in slope-intercept form. Y equal negative 3x plus 2. The other one, y plus 3x equal negative 4, well, all we got to do to get that in slope-intercept form is move the 3x over to the other side. Here it was positive, here it becomes negative, so that gives me y is equal to negative 3x minus 4. So, are they parallel? Yes, they are parallel. Because both equations have a slope of negative 3. So because these two, once we put them in slope-intercept form, okay, because both of those are negative 3, it doesn't matter what the y-intercept is. Okay? Eventually they'll talk to you about perpendicular lines. Perpendicular lines, the slopes, trying to remember, the slopes are opposites of each other. They're actually reciprocals of each other. Okay? Huh? Okay. All right, now, I want to look at one that may be a little confusing to you. Number 20 says y equals 6 minus x over 3, and they want to find the slope and the y-intercept. Okay? Well, on that one, you just simply have to take and this is y equals 6 over 3 minus x over 3. Okay, slope-intercept form means y equal negative 1/3 x plus 2. Huh? Because x over 3 is the same thing as 1/3 times x. Just like x over 5 would be 1/5 times x. Okay, x over 12 would be 1/12 x. Okay, now the actual answer is the slope equals negative 1/3. The y-intercept equals 2. Okay, and they don't want you to graph those, so you don't have to graph it. Now, number 44. Number 44 says 5 times x plus 3 plus y equal 10x. Okay, it's still the same. It's still the same things that we've talked about in Chapter 3. We just have to distribute the 5 to everything inside the parentheses. Now, there's another way you could do it. Okay, the other way that we could do it, which realistically might be a little easier, is to get rid of the 5. How do you get rid of a number in front of the multiplication? Caleb? Right. So in this, we could just divide this by 5 and that by 5. And that gives us x plus 3 plus y equal 2x. Okay? And I'll show you the other way here in a second. Now, we take the x over here and we take the 3 over here. It was positive and positive here, so it becomes negative and negative there. And so you have y equal negative x plus 2x plus negative 3. Okay, taking the x over, it became negative x. Taking the 3 over, it became negative 3. Now, you put these two things together, and that gives me y is equal to 1x plus negative 3. So the slope is equal to 1. The y-intercept is equal to negative 3. Then I have to graph it. Okay? Now, if I was to distribute like I talked about first, you would have 5x plus 15 plus 5y equal 2x. Okay, and that would give me 5y equal negative 5x plus 10x plus negative 5y. Or no, 15. 15. Okay. Then you have to divide everything by 5. Okay, and you give you y equal negative 1x plus 2x plus negative 3. Oops, hang on here. I did that. That's not negative 5. I'm dividing by. That's right there. And then that gives you the same thing you had right here. Those two are the same. Okay? And so that gives you still the y equal x plus negative 3. Okay? So, same thing. Get the same answer. Obviously, it's a little easier if you just divide both sides by 5. Okay? Then you would have to graph that. Okay, you would graph that right there. Now, what it means when you have a 1 as a slope. When you have 1 as a slope, negative 3 is right here, 1, 2, 3. There's negative 3. It is a positive 1 slope, so you go over 1, up 1. Right there, over 1, up 1. Okay, so you're basically just going to have this right here. Okay, and there's your slope triangle. Okay? Obviously, your line needs to go through the negative 3 one down there, but... Huh? I went to the right, which is positive, and up, which is positive. It's a positive slope, so I can't go to the right and go down. I went 1 and up 1 for a slope of... So for a slope of 1... That means your rise over run is 1 over 1. Okay? Now, your homework. You will have a test on Chapter 4 on Wednesday. We will review for it tomorrow during class. Your homework is this. 4.6. 14 through 54 even, and then 56 through 58, and 66 through 70. It's actually like 26 problems. No. Half of them you don't have to graph. You may go.